This conference will now be recorded.
Hello, everyone. Good morning, good afternoon, or good evening. I guess there are two members who will not be joining today. Okay, that's fine. Let's continue with the class. So, yesterday we have done a fantastic concept that was software management, YUM and DNF. I hope you might have completed that practicals because in the coming time, everything will be installing software and doing the task. All right. Now today we are going to talk about another very important chapter, which is called as managing processes, or in short, you can call it process management. See, process can be anything that runs in foreground or background. Any activity that goes on in the system is called as process. And every running activity will be consuming resources of the system. Now, it might be consuming memory, CPU, network, hardware, anything it might be consuming. Now, running too many processes and leaving it unattended will degrade the performance of your system. And as a system admin, it is our responsibility to check for them and get rid of unwanted processes so that the performance of the system can be increased. Now, each process will be identified by an ID, which is called as process ID. In short, we call it as PID. Now, this process ID is unique to every running activity or every running process. Anything you want to do with that process, you need to first find the process ID. And with that ID, we have to take necessary actions. Now, how many types of processes do we have? See, we have basically three types of process: interactive processes, system processes, or automatic process. Interactive process is nothing but the process with which you can directly interact. For example, VI editor or cat command. When you open the file in VI editor, if you say YY, it copies the line. When you say DD, it deletes the line. Am I not interacting with that? Yes. So such processes with which we can directly interact are called as interactive processes. Second processes are system processes or daemons. I mean, day before or 2, 3 days earlier, we have talked about these system services. Now, these services are called as system processes, which are owned by system. They are also called as daemons or services, which you can start, stop, restart, reload. You can enable, disable, all what we have learned. They are needed mostly by very important applications. The last thing is automatic or batch process. See, automatic processes are those with which you can uh, schedule something, and on the given time it is going to start on its own, like cron job. You schedule the date, time, event, and as soon as the date and time comes, automatically the event will take place. So such processes that can run on their own are called as automatic or batch process. Now we have one more category of process, guys, which is called as parent and child process. So what is that parent and child process? See, guys, whenever you start one process, automatically in background, it may start one more process. So first process which we started will be called as parent process, and the process with that process started is called as child process. So guys, for example, let me give you an example that I have typed ls-l. This is my first process. Maybe I have also used pipe grep. So ls-l will be called as parent process, and grep will be called as child process. So my mother process is ls and the child process is grep. Now usually what happens guys, that whenever you kill parent process, automatically child should also get killed. But in some cases what happens, the parent might get killed but child would be still running. Now, what do we call such processes whose parent process is killed, but the child somehow skipped and it is running? Such processes are called as zombie process. See, zombie processes are not good for the health of the system. And if we find zombie processes, they are not needed for the system, we should consider killing them, right? So what is zombie process? A zombie process is a process whose parent is killed, but the child is still running unnecessarily. How to find zombies and kill them? We'll understand in a short while. Okay, now let's log in into the system and let's do some important practicals. Now, if I want to see how many processes that are running right now on my terminal, so I'll go with a command ps. PS stands for process status. So it is telling you are connected to terminal 0, and on terminal 0 there are two processes running whose IDs are 2073 and 2099. What are those processes? One is bash shell and the other one is ps command. Now guys, these are open processes what we have seen. Now in the background also on this terminal there might be many other processes running. How can I see all the processes associated with this terminal? You can go with ps-a. So ps-a will show you all the processes which are associated directly or indirectly with our terminal. Okay. Now, not only this, as a root, you can monitor what other users are doing. For example, I'll be logging as my user and let me do some activity. Oh, did I change the password? Okay, fine. So let us say that as my user, I'll be editing one of the file. Now, as the root, I want to check what my user is doing. So I'll say ps hyphen u. You can use capital U or you can use small u. Both are fine. Any u is done. ps-u and the username. So this will tell you all the process which are associated by that user, including that VIM, what we are running. Now, if you observe, the processes are telling they are attached to which terminal, and there are few processes which are used by this user, but they are not attached to any terminal. You are getting a question mark over here. So what does that question mark means? Question mark means that they are background important processes which are not attached to any kind of terminal, right? They are important background processes which are running in the background. So all important processes which are not attached to any terminal will show question mark. See, what happens is when you log out, the terminal will be killed and all the processes running on that terminal will be killed. Now, suppose if SSH is killed, nobody will be allowed to log in into the system. So SSH cannot be attached to any terminal. It always runs in the background as an important process. Okay. All right. Same way you can check processes related to a group, provided there must be a process related to that group. It says that group does not exist at all. Maybe SAP GRP. So it says there is no process associated to SAP GRP. Great. Now, these are either the process attached to a terminal, related to a user or group. I want to see all the processes in my system. So you can say ps hyphen EF. Show me all the processes with its effective fields. So you see when I hit enter, it displays that which user owns that process, what is the process ID, what is the parent's process ID, who is the parent of that process, at what time the process started, is it attached to any terminal or not, how much time this process was active, and what command has started this process. So that's how it is giving you the detail. But guys, if you see, it is not telling you the status, whether the process is sleeping standby or running, or it is a zombie process. To know the status of a process also, you have to repeat the command by adding ELF. So L will give you even long form listing in which you will find there is S. S stands for status. Now in status, it is showing you S for sleeping, I for kernel threads. So ignore kernel threads. See what happens, kernel and CPU will exchange information in the form of threads. So it is showing you those threads and all. So ignore it. S for sleeping, R for running, and Z or Z is for zombie. So here you can find out if there is any zombie process available. Now, if any zombie process is available, you can consider killing it. Also, I wanted to see the usage. Each process is eating how much CPU, how much memory. I want to check that. So for that, I'll go for ps-aux. Now, when we hit enter, this will give you each process is eating how much percentage of CPU and how much percentage of memory. So that's how it is going to display the usage that each process is taking how much CPU and how much memory of your system. All right, fine. Now let's try to see a little more detail. Signals. Now what actually do we mean by signal? Normally guys, we come across many signals every day. When we go out on road, we see traffic signals. If it is red, that means it is giving us a message to stop. If it is green, there is a message that I can continue now. I can drive now, isn't it? Or I can move now. Same way when you are driving a car, if you want to take a left turn, you give left indicator. So that is a signal that you are taking left or you are taking right, whatever it is, right? So signals are nothing but messages, what you send to anyone or what you give to anyone. Now in Linux or Unix also, we can send signals to a process according to which the process will behave. Now out of all, there will be a deadly signal. If you send that signal to any process, it is going to kill that process permanently. Now how to use signals? To use signals, we have a command called kill. Now kill, if you want to see how many signals are there, you can say kill hyphen L. So it displays a huge list around 64 signals it is sending or showing. Now out of all, you see signal number one is for SIGHUP. Whenever you say systemctl reload, you're actually sending SIGHUP. Let me show you. If I say systemctl status crondy, right? So here is crondy. I'll say systemctl reload crondy. Now you check. Did you see what signal it received? Hup. Hup means what? It is going to reload something in that process. So signal number one is reloading. Signal number two, interrupting. Suppose some work is going on and if you want to break it, you press Control C. So Control C is nothing but breaking a signal, right? Or interrupting something, right? Same way, you have signal number 9, very dangerous. Signal number 9 is killing a process, one of the deadliest signal. Same way, signal number 20 will stop a process and send it into background. Running process can be stopped. Same process can be start again by using SIGHUB. But guys, 99.9% signal number 9 is that which is used widely. For what? For killing a process. Any process, if it is misbehaving and you want to kill it, we use signal number 9. I'll give you an example. I'll go with ps-u and username. Now I came to know that my user is using vim editor. Now I think that it is useless and I have to kill it. How can I kill it? You need to send a signal. How to send a signal? Kill hyphen signal name or signal number. Signal name, you can use hub or init, or number is just simple signal number 9, 1 to 64, any signal, followed by process ID. What is the process ID? 2213. See, as of now, the work is going on. Maybe this guy is working on that file, my user, right? When I hit enter, come back and see, you will find that the process, it says that it is killed. Killed means it is gone, finished, right? So this is the way we can use skill minus 9 to terminate any process which is misbehaving, including zombie processes also, right? Now, moving ahead to the next topic, that is priority. Now again, guys, if you just relate this word priority to our day-to-day life, we have our own priorities, isn't it? What is earliest, we'll do first, and whatever can be done later, we will avoid it and put it into backseat. Same way, in our system, there are lots of processes that are running. Now, not all processes are important to us, right? So what I wanted to do here is only the important processes I want to give high priority. Maybe our production application is running, and you know, production application is very, very important for our business. So I want it to perform well. I want it to get good CPU, good memory, so that it may give best results. So when many processes are running, out of all, if any process is very important to you, you can increase the priority. When you increase the priority, automatically it gets more CPU, more RAM, and performance will be higher. Okay, so how we can deal with priority? By using something called niceness or nice value. There is a concept called nice value which decrease the priority, and the nice value range is -20 to +20. Now listen to me carefully here, guys. Lower the nice value, higher the priority. Higher the nice value, lower the priority. For any process, if you give -20, that means you are setting high priority. It will always get good CPU and memory. If you set +20, that means you are giving low priority and its performance may not be guaranteed to be best. Now, whenever you start a process, by default, a process will start with 0, neither low nor high. Okay, so nice value, if it is in minus, higher the priority. If it is in plus, lower the priority. As simple as that. Okay, all right. Now let's move ahead and let's learn how to set nice value. One more thing we have to understand here, that nice value can only be set by root user. Normal users will not be allowed to deal with nice value. So first requirement is you must be login with root. Now let me log in as root. Now there are two scenarios in which you will set nice value. Scenario number one, whenever you are starting a new process. For example, I want to start cat. I'll say cat greater than hello. Now what I'm doing is I'm running a process called cat. But before running cat process, I want to set nice value so that it may get low priority. Maybe I want to give it low priority. So you need to say nice hyphen n, whatever value you want to give. So I'm telling nice, set the value to 5 and then start a process. So first I'm setting a priority and then I'm starting that process. So this is called setting up a nice value and then starting a process. Okay, let me hit enter. So your cat process started with a nice value 5. How can I check the nice value of any process? To check the nice value, we go with the same command ps-elf. Now, when you run this, you will find there is an option ni, which is showing you nice values, whatever nice value a process has been set up. Now, if I say ps-elf and let me grep for cat command. So you see here is your cat command and the priority is 5. So we have started a process by setting up a nice value called 5. Now I realize, guys, that maybe I have kept a low priority. I want to change the priority and I want to make it -3 or -4 or -5, whatever. Now I want to change the priority of a running process. How can I change the priority for a running process? We'll go with another command. Last time we used nice command, but guys, mostly people use renice only. They start the process randomly and then we change the nice value by using renice command. So I need to say renice whatever value. For example, I want to set -8 for which process? 2409. So you see it says old priority was 5 and new priority is changed to -8. Great, fine. Now you just go with ps-elf, grep for cat, you will find that priority is -8. Now, whenever you change the priority to minus, you will feel that the application will start performing well. Especially when the peak hour of the business is there, lots of applications are running, and you're not finding proper performance of application, try changing the nice value. And it is definitely going to increase the performance of your process or application. Okay. All right. Now, one more thing. See, as a system admin, we should also monitor the important resources of our system like CPU, memory, IO, network. These are all very, very important uh, pillars of your operating system. If any pillar falls, your entire operating system will be fallen down. So we should know how to monitor and how to check the details of their usage. First, let us start with CPU. CPU is nothing but the processor. So to check the processor details, we can go with ps command, what we have seen already. Now the command what we are going to learn is SAR or SAR, System Activity Report. Now when we talk about System Activity Report, I don't know why it happened, but in Red Hat 8, SAR command is not installed by default, but it is considered as one of the important monitoring command. So if it is not installed by default, we should install it. Now you remember yesterday we configured DNF server. Now you'll see another beauty of DNF server now. The beauty is when you run any command, if that command is not found, DNF will tell you if you install so and so package, you will get that command. See, in a while, it says if you install sysstat, it is going to give you SAR command. Would you like to install it? Definitely go for it. One more time, the question will be asked. Just say yes to continue. This is the beauty of DNF, which was not there in Yum also. So you see, systat package is installed. But if you check the service, systemctl status systat, you'll find that this service is inactive. It is enabled, but it is inactive. That means right now it is not running. After you reboot the machine, it will run. So I cannot reboot the machine to just make sure service is starting. I'll start it manually. I'll say systemctl start systat. Is it running? Yes. After installing and starting the service, we should go with SAR command. So you see it started to work. Now, just now, a second before it started, so it has no information for us. But if these services are running and whenever system restart, it gives us information in the fashion. It tells us that what time the system has started. Like it is telling here, the system started at 7:22 a.m. And after that, every 10 minutes, what is the performance? 7:30, 7:40, 7:50. How much CPU was utilized? All. By whom? Percentage of CPU used by users, percentage of CPU used by NICE process, percentage of CPU used by system process, and how much time it was waiting for any input to happen, right? And was there any stealing happened, zombie activities, and how much time the system was idle. So you can continuously run this SAR command and view the output. Maybe an important application you are running. So on other terminal, you have started the application. On this terminal, you want to see its effect on CPU. So on one terminal, we will start the application. On the other terminal, we will run SAR1. One means repeat SAR command every 1 second. It is the time interval. So every 1 second, I want to repeat the command and see the output. So you see, it is repeating. So with this, you can see live effect of the applications on this particular process, that while running that application, what is the effect we are going to get. Okay. All right. To stop it, sig int control C. So we have interrupted it, right? Fine. Now moving forward, let us say I want to repeat this command every 1 second, but only for 3, 4 times. After that, it should stop automatically. So I'm telling SAR, repeat it every 1 second, but only for 3 counts. So when I hit enter, just 3 times, the command will be run and automatically it is going to stop. So 1 is time interval and 3 is number of counts you want to do. Okay. All right. Now, if you want to see details about your CPU, you can actually go to a file proc CPU info. This is going to describe your CPU. Same information you can run by a command also, lscpu. Actually, lscpu will go to proc CPU info and get the information. So file location is proc CPU info. Command which is gathering the information is lscpu. What is the architecture? How many CPUs are connected? How many threads are there in your um, CPU core? How many cores are there? How many sockets are there? What is this sockets, core, and threads? In your motherboard, you can see there is a place where you can connect CPU. So this place where CPU is fixed is called as socket. And in that socket, you will put CPU. CPU will be divided into cores, 1 core, 2 core, 3 core, 4 core. and each core will be divided into threads that will be carrying your tasks. So it is telling you how many sockets are there in a socket, how many cores are there in a core, how many threads are there, like that. And then it is also telling us that what is the model we are using CPU. It's genuine Intel, family 6th version, model 78, model name is Intel Core i7. And what is the speed, hypervisor, all that details it is giving us, right? Fine. This is how we can deal and check the information about CPUs. Now let us say I want to deal with memory. Now guys, when we talk about memory, we can gather memory information by using free command, swap on command, right? We have already learned that in swap classes. Now the command what I wanted to go for is vmstat. Now when you run vmstat, this brings many information in her feathers. VMstat will tell you how many processes are running, what is the memory detail, how much swap memory is used, how much is free, how much is in buffer, cache, swap detail, how much swap in and swap out is going on. IO input output block in and block out that are being going on. System processes, CPU, how much processes are user based process, system based process, how much time it is idle, waiting, stealing, all that. But again, this is earlier information. If you want to see the live status, what is going on, then you can go for vmstat 1. So on the other terminal, you can start application. Here you can run vmstat 1. Every 1 second, it is going to repeat the command and show you the performance, how it is going on. If you want to stop this process automatically after some counts, you can say vmstat 1 followed by 3. So automatically after 3 counts, the process is going to get stopped. Okay. You can also check your memory detail by going into cat proc mem info. Last time we saw CPU info. This time it is mem info. Or you can go with vmstat -s. This will tell you memory detail, what is total memory, how much is used, how much is active, inactive, how much is free, buffered, swap detail, how much non-nice fellows are using memory, how much nice fellows are using it, and all other details it is going to tell you. Swap in, swap out, all that thing, right? Fine. Now let's see network or IO, guys. I'm sorry. IO, when we say IO is nothing but input output, which are your disks, partitions, LVMs, etc., where reading, writing, all activities are going on, right? So in which you can read and write. Obviously, on your hard disks, partitions, or your LVMs, you can read and write the data. How to monitor the disks and all, we have learned long back, fdisk, parted, df, all these commands. Now the command we are going to talk about is iostat. When we go for iostat, enter. First two lines you see, it is the same lines what you have got with sar command. If I run sar, here also you will see the same thing. The first line, I'm sorry. So first line is exactly same. And when you repeat it, it is going to give you same result, SAR 1, 1. So you see, are we getting the same thing? User, system, IO, waiting, stealing, all that thing. After that, if you see, it is talking about devices. How many devices are connected to my system right now? There are two disks. One is SDA, the hard disk. Second is SCD, that is your CD or DVD drive. Now over here it is telling you TPS, transfer per second, which is also IOPS, input output per second. How many input output it is doing per second? 7.23 IOPS are going on. And here it is giving you little detail per second what is the reading speed of that device, and per second what is the writing speed of that device. So far how much reading and how much writing that disk or that device has been done. Again, it is giving you previous information. If you want to see the live information, you can go with a command iostat 1. Every 1 second it will repeat the command for us. And if we want to limit it only for 2-3 counts, you have to say iostat 1 followed by 3. So automatically after 3 counts, this iostat command will stop. Okay. Now let us say that in my system, I have many disks, many partitions. I don't want to see the details of all the disks attached or all the partitions. I just want to see only the performance of one partition. When you run fdisk, you find there are many partitions. Maybe I want to see the performance of SDA5 only. So what can I do? You have to say iostat-d and the device name is SDA5. So it is only going to target SDA5. Or you can say SDA5 and SDA7. Two disks or two partitions it will monitor. It can be logical volumes also. You can give dev vglv name, so it will monitor that logical volume only. Now if I wanted to see it continuously, same process, 1 3. So every 1 second for 3 counts it will repeat, and then automatically it will stop. Okay, all right. Now guys, I want to see network details. Few commands I have shown you in network class, like ping command or ifconfig command, ETH tool, MII tool, ping command we have seen. Now the command we are going to learn is netstat. We have also seen netstat as well, few of the thing. So if you remember with netstat, by using NTLP, you can monitor which service is using which protocol, TCP or UDP. NTULP if you run, it will show you all TCP and UDP related services. SSH is using TCP and VSFTPD is using TCP, right? Like that, you can get the information. Listening is nothing but it is active working. Okay, all right. Same way, you can use netstat hyphen nr to check routes or gateways that your system is working with which gateway IP. So you see here it is displaying that our machines or our machine is actually working with a gateway 10.1, 192.168.10.1. Also, if you want to see details about your adapter performance, you can say netstat-i. Now this will tell you that your Ethernet adapter has sent how many packets outside, how many packets were having error. That means maybe you have typed wrong IP address, something like that. And how many packets got dropped. You tried to connect to other machine and firewall stopped. And how many packets have been moved to other location, like that. So with a frequency of 5 seconds, something like that, it is showing in two pieces. Now, if I want to continuously monitor it, then I have to say netstat-i1. So every 1 second it will repeat and show you the live network information about your adapter. Also, guys, there is a wonderful command what every Linux administrator should know, must and should, and that command name is top. Guys, in Windows, we have Task Manager, right? If you go to Task Manager, it is going to show you all the ongoing processes, how much CPU memory it is consuming, right? Other details also it will show you. If any process is misbehaving, you can right click and kill that process. Very simple tool is there and beautiful. So if I want to do the same thing, then there is a command called top. It's very much same like Task Manager, but it is a command line tool. So when I hit enter, you see a dynamic window open, which is keep on changing. So it's a live performance tool. On one terminal, you can run application. On the other terminal, you can run top and you can live see what's the effect of that application. Now over here, the first line is showing you same uptime command. What is the time in your machine? And your machine is up for how many minutes or hours or months or weeks? How many users are logged in, and what is the CPU usage, current usage, 5 minutes earlier usage, and 15 minutes earlier usage. So it's an average of 5 minutes, 10 minutes, and 15 minutes like that, right? Then total how many tasks are going on, out of which how many are running, how many are sleeping, how many are stopped, and how many are zombie. There are no zombie, that's a good thing. Then it is giving us the same CPU and memory swap detail what we have learned by IOStat and sorry VMstat and other thing star command. Now at the bottom you see it is showing you what process ID is using it, to which user it belongs to, what is the nice value, what is the status. R means running, S for sleeping, Z for zombie, and I is kernel threads. How much CPU memory it is consuming, how much time it actively used the resources of your system. So it is the active time, the time it was active and used the resources, and to which command it belongs to. For more details, guys, I would recommend you to please visit our manual, and here you can get each line detail, everything. Now I have segregated, in fact, few commands. See, top is very much same like fdisk. Like fdisk will have P for print, Q for print like that. Top command will also have some commands. Now, if you don't know what is the command, you can type H. When you type H, it lists the help, all the commands what you can run. Lots of commands are there, guys. To simplify it, I have a list of commands. M to arrange the output with respect to memory. I want to see only memory intensive programs. The processes which are using high memory should come first. So I want to arrange the output with respect to memory usage. So you have to run capital M. You don't have to hit enter. Just type capital M. That's it. Shift M. So you see highest memory consumption is 11%. That is done by gnome shell. Then 5.9, 3.2, 2.6, descending order, it is going high to low. If you want to arrange the output with respect to processor or CPU, then I need to go with capital P. When I run capital P, you see the output is arranged with respect to processor. Highest usage of processor is 1%. So there is no real usage that is going on with this particular process, right? Fine. Moving forward, I also wanted to see the processes that were active. I want to arrange the processes with their active time. So I can go with capital T. When I go with capital T, you see the highest running process was 18 minutes 52 seconds. Then 1569, 1527, 694. It has arranged according to the time it was active. Okay, all right. Then you can also display the output in colors. I should have shown this first. See, the output is black and white. You can turn it into color. Color pleases our eyes, and sometimes red color, very dangerous, can be very beautiful to identify intensive programs. So I'll go for Z, and you see it shows the output in colors. Now let us say I want to find a process. So you can use capital L to locate or search any process. When I type capital L, it asks, what is the process you want to search? Maybe I want to search. It can be any string. It can be process ID. It can be name, initial characters, whatever. So when I say cron D, you see it searched and brought cron D at top. So it says cron D is this. These are the details. Now, if you see the nice value of cron D is 0, maybe I want to change the nice value now. I want to increase the performance of cron D. So how can I change the nice value of a running process? If not in top command, you have to run renice command. But in top command by using R, R will allow you to renice. So let me say R. It asks which process. What is the process ID? 1221. What is the nice value you want to give? Maybe -5. So you see the nice value is changed. So within this top box only, you can do, it's like the task manager right clicking and doing something. The same thing we are doing with command line. Now, maybe this process is misbehaving and it is giving lots of trouble. It's just hanged or something like that. So I want to kill this process. How can I kill any process? To kill a process, we have to go with K. K to kill a process. So I'll type K. It asks which process you want to kill. 1221. That is your cron D. Now hit enter. It asks which signal you want to send. Shall I send 15? I'll say no. Send 9. Deadliest signal. See, in a while, cron D will kill. Gone. Right? So that is where this particular top command is very useful. Now, if you want to come out of this box, you have to type Q. Q for quitting this tool, and you're out. This is the way, guys, how we work with this concept of um, top command and all. This is all about, guys, process management. Now we have done with our normal Linux administration, important Linux administration. From Monday onwards, we are going to work with our final few very important topics in Linux administration, that is servers. It's like we have peeled off the fruit. It's time to eat the pulp now, and that is your servers. So we are going to talk about NFS server, DNF server, DNS server, or Samba server, web server, right? Mail server. So what we need to do over here is we need to brush up our previous exercises. 2 days you have Saturday and Sunday. So brush up little bit user admin, networking, what we have done, SE Linux, services, firewall. Just brush up these things because these are the things, software management, what we are going to do in our next classes. So please do not come back without brushing up these topics. These are very useful. Otherwise, you may have little tough time understanding the concepts, and I don't want that to be happen. All right. So that is it from my side, guys. Now, if you have any queries or questions, you can put your questions now. Or if you don't have a questions, please give no questions so that we can stop the session. Okay, thank you. Farash, do you have any questions? Muhammad, do you have any questions? Okay, great. So we'll stop the session here, guys. Kindly brush up your skills. Our next classes are very important. After the servers, we will see Ansibles. So we must do very well at servers and all the previous topics so that we can work perfectly with Ansible also. All right. So thank you very much, guys. See you on Monday. There's no class tomorrow and day after. Have a nice weekend, safe weekend. See you on Monday, guys.